Hello everyone, welcome to today's webinar. We are the EECONE project and we are all about reducing electronic waste through innovation and collaboration. My name is Moritz Schlagmann and I'm very happy to introduce you in the first session. And I want to thank you on behalf of all EECONE partners for joining today. Today we talk about eco-design of electronics for e-waste reduction. So why are we doing it? The global and European e-waste is growing and we are not really keeping up with it. So instead of raising our recycling rate, only the waste is raising, and it is almost by a factor of 5. And therefore we came together and applied for this project to reduce it. So the EECONE project, we are guided by the 6R principles: by reduce, reliability, repair, reuse, refurbish, and recycling. And our 4 key objectives, therefore, are: first, we want to define green ECS. So we want to have a clear and simple and open tools to define the ECS for circularity. Then on the second step, we want to make green ECS, and this is what we learn about. What can we do about it? And also showcase the green solutions, and then building consciousness around us. Today we have 4 interesting talks. So in general, we are over 50 partners from all over Europe. And today we will hear interesting talks from Fraunhofer IZM in Germany, from IFAG in Belgium, from the Dassault System from France, and Nero Bianco from Italy. And I want to encourage you to ask any questions. Please put them into the chat and we will answer them after our presentations. And the first presentation is by Joop, and I would like to hand over to him now.
May I just, sorry, Moritz, there's a Q&A section, not for the questions. I think it's better than in the chat. There's a dedicated Q&A session. So if you want to have questions after this presentation, please add your questions directly in the Q&A section of this webinar.
Thank you.
Thank you, Moritz, for the kind introduction. Is this full screen visible for everybody?
Yes.
Perfect. Thank you. Yeah, so I want to give a brief overview of how basically EECONE addresses the challenge that Moritz just introduced through collaboration. And collaboration really is key because this is a very heterogeneous problem, right? There isn't one specific problem for one specific application. It's very widespread and everyone has different objectives, but still we have a common approach for addressing that, and I will briefly go over that. So in principle, at a very high level, all of us have here the same goal, which is to have sustainable electronics. So that's a very kind of shared objective that we have. But what sustainable electronics means is different for everybody. The way that sustainability is typically assessed is through life cycle assessment, or LCA. And LCA follows the 4 steps that are shown on the bottom, where you first identify the goal and scope of your research. And then you follow the 3 other technical steps after that to basically actually execute the research. But this first step is, when you think about sustainable electronics, it's very different for different applications. For instance, within the EECONE project, we have 10 specific use cases, we call them, which are different applications where we try to achieve different objectives, such as having low impact technologies, reducing e-waste, reusing components, improving reliability, or increasing recycling, for a whole variety of applications. So the goal isn't necessarily the same in each case, and neither is the scope, because you can see here, and this is not even like an exhaustive list, it covers things from sensors to servers to soil probes. So it's a very heterogeneous project. Now, then the question becomes, how can we address such a wide array of problems through one approach? And that is basically coming back to the point of collaboration. So I make here the analogy of a toolbox. And say you have a toolbox with only one tool, say a wrench. You might even have different sizes of wrenches, but you can only address problems with that for which a wrench is useful, right? You cannot really hammer in a nail. Well, you can try, but it will not be very good. So better than having a toolbox with only one tool is, of course, to have a toolbox with a wide variety of complementary tools that kind of together help you solve a problem like building a house, or in our case, making electronics sustainable. And in EECONE, we have this toolbox, and it's being developed even better and better as we speak. And what I'm trying to show here is kind of the wide variety of tools in the toolbox that are in use and in development within the EECONE project. You can see that various levels of sustainable electronics are being addressed, from the IC chip level at the bottom up to assembly and even system level evaluations, with a wide variety of goals and a wide variety of scopes. I'm not going to go over all these tools in detail, but I highly recommend looking into the ones that are of interest for your specific application, your specific study. But the main thing I want to show here is that by combining different expertises from different organizations that all bring their strengths to the table, you can address a wide variety of complex problems. So what does this approach rely on? Only two things. Firstly, the tools need to be good. And secondly, the collaboration needs to be good. Good tools. I take here my own tool, not because I think it's the best one. In fact, every tool has a very different purpose. This is just the one that I can answer questions for because I know it. So for instance, this is one tool that we develop to assess the environmental impact of IC chip manufacturing. And it goes into quite a bit of detail where you can select options. For instance, I want to assess a CPU, or I want to assess a memory technology from a certain generation, die size, from a certain fab with specific properties. And you can then put all these parameters into the model, and it will basically build a bottom-up fab model around it to then ultimately generate things like the climate change impact or the amount of resources being depleted. And this is basically just one of the tools. This applies to the evaluation of ICs for the specific purpose of environmental impact assessment. But as I showed on the slide past, at a variety of levels in the system, you can use complementary tools from complementary organizations. Then, of course, the second part that is necessary is good collaboration. The way that we do this in EECONE, we have a use case, which is basically a certain application that wants to become sustainable. And then we have the tool makers that provide tools like the ones I've just shown on the last few slides. It is up to the use case lead to go to the various tool makers and say, this is the information I need from you. For instance, we need to understand how much we can reduce the carbon footprint and material use by making a thinner printed circuit board, which is something, for instance, that the ATNS tool can help with. Then the tool maker, in this case ATNS, can support a use case lead to meet the need by basically specifying, okay, these are the parameters I need for your specific application, and then we can support your exercise of becoming more sustainable in your electronic products. And then, of course, there needs to be mutual clarity on these are the assumptions I'm making, and this is the methodology I'm using to answer your specific need. And this is really, in a very brief overview, why our approach is I believe, so strong, because we combine good tools that rely on the expertise of a broad variety of very experienced organizations within the European ecosystem, with good collaboration to address these use cases with a right variety of scopes and goals. And of course, this approach is not limited to the ones that we're currently studying in EECONE, but the approach is generalizable to an even wider variety of applications, with the ultimate aim of course, working towards sustainable electronics across the supply chain. And that's basically what I wanted to share briefly on the scope of EECONE and how it helps and how it can also help your specific applications by following this approach. And with that, I would like to very much thank you for your attention.
Thank you very much, Joop. With that, we hand over to our next presenter, Lena from 3DS.
Okay, just 1 second. Are you able to see the full screen?
Yes, looks good.
Okay, perfect. So hello everyone. Today I will present the topic of embedding user-centered design in LCA tools. And I would like to present also insight from what I call the usability test session. So in other words, I will talk about how we brought real users into the tool design process and what we learned from it. Because eco-design, it's not only a matter of data or methodology, it's also about enabling people to use these methods efficiently and to make informed, sustainable decisions in their daily work. So for those who don't know me, my name is Lena and I work at Dassault Systèmes, where I contribute to the development of sustainability applications. And today I would like to share how a very hands-on, user-centered approach helped us better understand how our tools are used in practice and how this methodology can benefit any eco-design solution developed within the ECONE project. So, within ECONE, our goal is to make sustainability measurable and actionable. But to achieve that, the software itself must be usable, and that's where the user experience comes in. So you can have the data and the software. If the tool is too complex or unclear, well, the user will never reach the decision that leads to a sustainable impact. And if the people who design sustainable products can't easily use the tools we create for them, well, even the best environmental methodologies can stay theoretical. So in our case, this reflection actually started with a question from our partner Leonardo, and it was a question about our LCA tool on the 3D Experience platform. So the question was, why isn't there an AI companion to help us? It's a fair question, but it reveals something deeper. If a user feels they need an assistant to navigate the tool, well, it means that maybe the tool isn't intuitive enough. And that's exactly what UX helps us uncover, because sometimes what looks like a feature gap can actually be a design problem in the software. And we wanted to avoid the temptation of to fix a design issue with more technology. So we're not against AI, but through usability testing, actually, we can be much more precise about where the AI truly adds values, and also where the real need is simply a better tool design. So especially as a sustainability team, this mindset is part of our commitment to digital sobriety, and also because we want to use new technologies where it makes sense, and not just because it's available. So let's look at how we actually conducted these usability test sessions within the ECONE project. So a usability test session, first, what it is a very practical UX exercise where a real user, so real user is someone representative of the target audience, and in this session, this user is invited to try a tool or a prototype. And the goal of this session, it's not to test the user skill, but it is to observe how the software itself supports or hinders their tasks. So it's one of the simplest and most effective ways to evaluate the tool design, because it reveals not just how the tool works, but also how people truly interact with it. The process is quite simple. It's a 3 main step process. So first an interview, then a hands-on test, and lastly a debrief. And I have to mention, this session wouldn't have been possible without the participation of 3 experts within the consortium. So Edmund Whitemore from Formod, Livia Kalusaka from Leonardo, and Teresa Thiaolter from Infineon. So a huge thank you to all 3 of them, because their time, their insights, and their honesty were absolutely key to this project. And together, our goal was simple. It was to observe how users naturally interact with our sustainability tools, to identify where the experience flows smoothly and where friction happens. So that's in that way we can build on strengths and improve what doesn't work collaboratively. So now let's take a closer look at what happened during each session. So every session started with an interview to understand the participants' role, goals, and even daily activities. So we spent about an hour discussing questions such as which tools do you currently use for LCA, what are the most time-consuming steps in your workflow, and even what usually causes frustration when using your usual software. And this first step, it helped us understand how they approach eco-design in their daily work, also their mindset, their challenges, their expectations, so we could build a realistic and meaningful scenario for the test. And speaking of the test, then came the practical part. So the participants were asked to complete a predefined scenario, so performing a life cycle assessment on a rather simple object. In fact, in our case, it was a skateboard. And also by following the environmental footprint methodology. So what we did, we provided them the necessary inputs, so the test product, its bill of material, and all the data needed to carry out the assessment, so they could focus entirely on using the tools rather than preparing the content. And they were able to work directly on the 3D Experience platform, so using 3 of our applications called Business Target Definition, Business Value Definition, and Sustainability Assessment. And the session took place on the Dassault System campus in Vélizy, so in real working condition. So it was allowing us to observe genuine user behavior, just as it would happen in their everyday environment. So we carefully observed how they navigated the tools and which feature they used, and even where they hesitated or got stuck. Finally, right after the test, we took a few minutes to debrief with each participant while everything was still fresh on their mind. And we asked open questions such as what worked well for you, which parts felt confusing, or if you could change one thing, what would it be? And this final exchange was often the richest part of the session because it helped us understand not only what happened, but why it happened. And its observation turned into concrete, actionable insights that we can use to guide the next design iteration to make the tool evolve. And sometimes a single sentence that was said out loud captured a problem within the workflow. So for example, I don't see how a designer who isn't an eco-invent expert could know which activity to assign, or even using this panel every day would be quite frustrating. So it was speaking about a feature to search activities and processes to assign to a part. And so after analyzing all the feedbacks, one thing became very clear. It's that improving usability, it's not just about comfort, it's a direct lever for sustainability and circularity. So now, how do we take all these insights into action? Well, every usability test session brings us a bit closer to the tools that people truly want to use. And each improvement that makes our tools simpler and clearer helps reduce not only digital waste, but also training time and frustration for the user. So we've tested here with our own LCA applications because it was simply the most direct way for us to implement this methodology. But actually, the same approach can be applied for any tools developed within the EECONE consortium or everywhere. So whatever the solution, the principle remains the same. If people can't easily understand and use a tool, well, even the best sustainability feature will stay unused. And from this session, 3 key actions emerged to move forward. So first, to simplify the workflows and remove friction. So to streamline the user journey so that action feels natural, to reduce unnecessary steps, and to bring clarity to complex tasks. But also to design what users really need. So we need to focus on meaningful features rather than just more features, and make every addition truly support real user goals, so especially when we introduce new technologies and energy-consuming technologies like AI. And finally, to listen, learn, and raise awareness. We need to keep the user feedback visible throughout the design and development and make this UX a shared mindset across the teams. Because one of the big challenges we face today, and we don't always see it, it is that it's not just about creating new tools for sustainability and even circularity. It's also making sure people actually adopt them, because many designers and engineers want to make better choices and reduce impact and design responsibly. But sometimes their goodwill gets lost when tools are too complex or when the experience becomes a barrier instead of a support. So that's why listening to user is so essential, because in the end, designing for sustainability starts by designing for people. And this concludes my presentation. So thank you everyone for your attention. And of course, I wanted to give a warm thank you to all the participants in this usability test session from the EECONE Consortium and Dassault Systèmes. So Edmund, Livia, Teresa, Olivier, Theo, Brian, Maria Victoria, thanks a lot.
Thanks, Lena. You did an amazing work. Thanks.
I can only agree. Thank you very much for the very nice overview and all the effort you put into it, and not getting away from the challenge, but also really including the user and the people. I think that makes a big difference at the end.
Absolutely. Thank you very much.
Now I'm handing over to Leo, talking about eco-reliability in electronic design. Page is yours.
Yep. Can you see my screen?
Yes.
Perfect. So now we'll talk about eco-reliability in electronic design. And we'll talk about new methods that we are working on in Fraunhofer IZM about sustainability technology selection. So my name is Leo Saillenfest, and I'm working for Fraunhofer IZM, an institute working on the environmental impact of electronics in general in Germany. So first of all, to introduce the approach is done to be used during the detailed design of an electronic product. So in general, we, like some companies, use the V model or other frameworks to create their electronic products, and you have different steps. You making a first architecture and then go further and further into detailed design, and that's where the eco-reliability approach should be used. And the eco-reliability is focusing on, for now, 3 out of the 6 R framework. And the goal is to find some trade-off between reducing but also increasing the reliability of the products, and focusing also on the repair. Let's go now further into the overview of this methodology. This methodology is divided into 5 steps. The first one is about the expected lifetime. Then you do a reliability study, repairability study before going to the environmental impact assessment. And you finish with a new metric, which is called effective environmental impact. And that brings these 3 topics together. Let's dive a bit into, first of all, through this approach, you will have to determine the expected lifetime of the studied system that you want to design. The goal is to really answer how long do you expect your studied system can live. So not the warranty time, not also a super long time because you want to have a product that lives forever, but more how long does your product should live before it's not used anymore. If we take the example of a Fairphone 2 motherboard, most of the phones today are used for almost 7 years. And after 7 years, more than 90% of the phones are not used anymore. So you have to take into account that this obsolescence is here because technology is evolving super fast. You can also take into account potential life extensions of the studied system. If we take this example of the Fairphone 2 motherboard, we have now some companies that are working on the reuse of the on this motherboard for example, Wi-Fi router, and you could expect that it could live 5 more years, and then you should design a motherboard that should live for 12 years, and your expected lifetime is 12 years. Once you've done this, Then you can focus, so first on the reliability study. The goal is to define both constant and aging failure. You have different ways to do it, through estimations, through models like Weibull model, or different information that you could have about the technology failure rate. You could also work with your supply chain to get these failure rates, or also work with predecessor products that are used in similar cases, or even do some tests or search in the literature. Once you get this constant and aging failure rate, you can focus on the maintenance and repairability of the product. In this part, you have to focus on, for each technology, what if the case of failure, what need to be replaced, how can we repair the product, what's all the process to do this. So in case of failure, what's the smallest part we can replace? So it could be just a joint in case of a joint failure. It could be the component also with it in case the component is also failing through the joint failure. Could be a submodule, or even in case of no possibilities to repair, it could be the entire product that we need to replace. And once you've done this, so you have to focus on the repair, the process to repair, and also on the fact that you, the company, or a third professional party, or the customer itself is able to do it. Because if no one is able to repair the product, even if the process to repair exists, then you should take into account that your product cannot be repaired, and then in case of failure, you need to replace the entire product. Once you've done the repairability assessment, you can focus on the environmental assessment of the technologies themselves. So for each technology, you should do the environmental assessment, and you can focus to ease your work only on the differences between the technologies. If you have some steps that are done in the two technologies, then you can avoid them. And once this is done, you also have to do the environmental impact of the repair process for each technology. Which means the production of the part to replace, the material and energy consumption use, and also focus on the transportation. And when this is finished, then you can bring everything into one new metric, which is the effective environmental impact. And this combines, so the environmental impact of the technology itself, like for the production, which is still here, and you have to add a certain environmental impact, which is the failure probability multiplied by the impact of the repair of the technology. And through this, you can find new balances and between repair, reliability, and environmental impact of the production. To have like a short example, I won't dive into the details of the example, but we did a study where we compared sintering and soldering to assemble 3 MOVsets on a PCB that got also other SMT components that were soldered on it. And we had to choose between soldering or sintering for these 3 MOVsets. For a product that first we decided to estimate a lifetime of 10 years. Here on the right, you can have the different process impacts. So the impact of the soldering is an order of magnitude of 10 power minus 3 or minus 2. Then you have the same for the, like a bit more for the sintering, the repair impact, and the replacement of a full PCB in case of sintering, in the case that for soldering, you can repair the components itself in case of failure, whereas for sintering, you cannot repair, you need to replace the entire PCB. Just you see global warming potential and ADP just to showcase that we can also not only focus on global warming potential, but on all the other impact categories. For the rest of the presentation, I will focus only on global warming potential. So once you've calculated these 4 impacts, you can see that today sintering is way higher than soldering if you just take into account the processes themselves. But if you include the failure probability, you finally find that soldering is 5 times higher, like more impactful than sintering by using our new metrics. So this is the goal of the tool. And then to finish, this tool can also go the other way around. Where should you put your money to improve the environmental impact of this technology? Where should you focus your time also? Is it in the repair, in the reliability of the products, or in the environmental impact of the production? So you can take into account, for example, if there is no maintenance, then in that case, you need to replace the entire PCB. It's increasing a lot the environmental impact of soldering, and in that case, you should anyways focus on sintering. Then if you want to invest some time and some money in the constant failure rate, you can see that finally it doesn't change anything to the results if you compare it to the main results. And to finish, if you want to invest the repair distance, so instead of repairing in the main facility in Germany, you use professional repairers a bit everywhere in Europe, not so far from the customers. Then you can see that soldering and sintering are the same order of magnitude, and maybe you will choose other topics and like or other parameters like the economical parameter or the brand image to choose if it's better to use soldering or sintering. Thank you for your attention.
Thank you very much, Leo, for giving us a methodology and explaining the methodology, how you can bring together reliability and repairability. Very interesting to find a good balance there. That's always not so easy.
Thanks.
Then I would hand over to our last presentation. There, enabling robust eco-design in electronics.
Yes, hello. I will share now. Yeah, wait a second. It's taking longer than during the testing phase, as usual.
I will let you know
I'm doing it.
Coming up.
Coming up, right. Let me know when you can see it.
No, perfect.
Yes, it's going. So let's go then. Well, first of all, thank you very much for actually inviting me to present during this slot. Basically, the focus here is in putting an eye on the EECONE platform and the market opportunities that it might open. I will go through it not from a pure technical perspective, but rather more from a strategic perspective. Actually, I'm a business analyst in my company, and what we usually do is to understand how also these digital tools that are aggregating resources and assets may be of benefit in the future for the end users. So basically, well, to cut a long story short, the other presenters have already identified what is the core focus of the project. And I think the fil rouge, which is actually leading what they told with the EECONE platform, is that we wanted in this project also to fine-tune and design something where we can aggregate tools and resources to support the eco-design. Actually, this is where the Ecodesign platform of EECONE ends up, which is part of work package 3. And to cut the long story short, it might be considered as a sort of modular digital ecosystem, right? Designed of course, to support eco-design of electronic components, of systems, by doing quite many things. Of course, due also to the innovative and research, let's say, nature of this kind of project, the platform is a sort of evolving creature, right? But you already can see actually promising future possibilities and potential for it. And as I always say, as my first employer, I have been working for SAP 25 years ago, when he said, as long as a person from the business department can easily understand where technical stuff is going to, then we are moving into the right direction. And indeed, the way the EECONE platform is currently being structured is structurally as a sort of catalog-based environment, while technically it enables the connection of design simulation and actually LCA tools, starting and through neutral data formats, which makes it quite attractive. This approach changed a bit during the lifetime of the project. Initially, we had in mind, or the consortium had in mind, actually to make it a more sort of 5-layer integrated system. But then we actually understood that it might ended up in a sort of too rigid environment, and so it switched to a modular catalog-based platform, where basically each tool that is in there, that I will then shortly present, is identified by an ID card, so easily identifying its scope, the data that are required, and how actually it supports the 6R logic. It makes it, of course, more interoperable, and we guess also more scalable, especially if we think about maybe medium or smaller companies that are trying to and are looking, as we will see later on in brief, in short, how to use things like this. The work was initiated actually by a sort of initial survey, where we have been exploring what R&D specialists or other experts would look and would like to find in such a platform. So there are here these 4 major items. So let's move away from these, let's say, long LCA reports, but they are looking for actionable and simple eco-design feedback, regardless the kind of tool that we have. They're looking for interoperability, good quality data sets to start from, and hopefully and ideally into something that is validated also through real industrial use cases. And that's exactly also where the EECONE project wants to make a sort of difference, by having use cases who, use case by use case, try to use and connect the different tools that we have. And I have somehow labeled the tools that we have. So we have, let's sort of 4 domains, more or less, and 9 tools that cover the entire life cycle and value chain of eco-design. So from design intelligence down into mapping, circularity, and energy consumption. And if you then want to look a bit more, I have also taken out the longer description of these 9 tools, which again currently are working like pieces of the puzzle, right? So let's say the left image is how they look like now, and based then on the necessities, in our case of the use cases, but of the company, all these tools can be put together or picked up depending on the necessity of the design. And this ends up to summarizing what is the current value proposition, according to us, of the platform for companies. It puts basically the eco-design and these tools into the daily practice. So it makes it has been designed to be rather more operational, and not to take and to consider eco-design as a sort of follow-up or simply compliance exercise. It provides transparent data and also the metrics, especially through the ID cards. It's ready for compliance because it aligns with regulation. And as I said at the very beginning, it makes this very scalable for SMEs. If I need 1 tool, I can pick up 1 tool. If I need more, I can pick more, and I can then leave the engineers to put together the appropriate workflow depending on their necessity. And how we see it in long term, of course, this is the most challenging thing. Well, let's say that the dream could be to make it a sort of European infrastructure for sustainable electronics design in the long term, where we should make sustainability measurable and comparable across different tools. It should also support and help to reduce the costs and complexity of the compliance processes. And most of all, what we would like to stress is that it changes the approach, moving from, let's say, understanding or keeping sustainability as a reporting exercise and shifting it into the sort of design capability. We did a workshop with some companies and said, okay, how could we really make a difference, right? Compared with what is existing out there, because of course this platform is not the only tool, that there are alternatives outside there. We had a workshop with 31 SMEs, they're all Italian SMEs. We invited also 4 Slovenian and 2 Austrian, but the core were basically Italian one. And well, there are of course strengths in existing alternatives like commercial LCA tools, open source tools, or checklists or PLM platforms. But as you see at the right side, the weaknesses is that most of the cases are expensive, the commercial one. The open source one are hard and for non-experts. If you use checklists, well, okay, they are easy, but actually they go low into the very deep details of what we have. And with PLM platforms, okay, we have a vendor lock-in issue. That's and in 27 out of 31 cases, this is the real limit of these commercial alternatives. And are there also other things that tell us that, okay, we are going into the right direction? Yes, because actually we did also another check of already, let's say, digital initiatives. There are quite many. I mean, we have just summarized a couple of them in these tables. But what is really making the change is that these kind of existing alternatives are more focused in finding green products, while what you want to achieve with the ECONE platform is to move into designing green products. So basically not tackling the issue from the end, but taking them and taking the issue of the opportunity of eco-design in our hands from the very, very beginning. To cut then a long story short, there is also policy momentum to continue to invest in this kind of platform. And also we see some ways of how transforming it into possible future business opportunities. So this kind of platform may open up the way to eco-design services for SMEs, for instance, or to deliver green data analytics for supply chain transparency to guarantee it, or even if we see it even in the longer term, to have a sort of digital twins feature which combine functional and environmental performance. Of course, this will take still some work. Here's some milestones in the roadmap to 2026 and beyond. It would be wonderful after the end of the project to have a sort of concrete pipeline and to keep this momentum going and the platform really up and running, supported by all our use cases, and lead it to a sort of long-term governance scheme and its market launch. Yeah, so that was it from my side. As I said, I didn't dive into the technical details of it, but actually we are very convinced in terms of its business potential, and also supported by the feedback that we already had with first, let's say, SME peer reviewers. We had a chance to look into the first details of the platform. Thank you very much.
Thank you very much. And with that, we are coming now to the Q&A session. And there I would ask our moderators and also our presenters to turn on the camera again. And then I would hand over to Chiara and Olivier.
Actually, I don't see any Q&A in the list, but I don't know if our audience has some questions to ask. This is the right time. I think we have seen some very interesting presentations. So I'm surprised we don't have any questions. So feel free to ask all the questions you might have. We have some time, so go ahead.
For questions to come, I just want to add something about the presentation of Andrea. Andrea told about transparent data and metrics. About metrics in ECONE, we we made a collection of a set of metrics that support environmental impact assessment and the anticipation of the circular economy strategies. So we did this work during the first year of the project. We collected with the partner a set of around 100 metrics. For each metric, we specified the circular economy strategy. It supports among the 6 R of ECONE the purpose of the metrics, if it is a metric to monitor the progress about the environmental impact reduction, or if it is intended for a comparison during the design process. We specified the design level to which the metric applies. So I think PCB system level, you saw the levels in the presentation of Job. Now we have just published a first set of the metrics where we divided the metrics in various categories, considering the different nature of the metrics for the eco-design. So we can have metrics for environmental impact assessment. We can have metrics for optimization for environmental impact reduction, reliability, circular economy. Then we have some metrics about an environmental score, and also we start looking, we have some partners looking to absolute sustainability. So we published this first set of metrics. I can put the link of the file in the chat if you want to see some examples. It is not the final version. We will publish the final version of the metrics before the end of the project.
I don't know if everyone can access Chiara, but I tried, and the link is working. So.
Okay. We have a question. I wanted to ask about the consistency of the data sources. How do you combine different sources, LCIA methods, etc.? Also, there seems to be a focus on global warming potential and IDPE from IMEC and Fraunhofer. Global warming potential is clear, but why the abiotic depletion potential alone and not other categories? So I think this is a question more for Leo and Job.
Yeah, you can also start, Leo, if you want.
I can justify why ADPE is just, I wanted to show that we can use different, we can use the tool for different impact categories, not only for global warming potential, which is the most well-known today. I could have put water use, for example, which is also quite important. Just I didn't want to make it really full with all the impact categories, so I just choose ADPE. And in the case of sintering and soldering, as you have silver in it, ADPE is the most relevant after global warming potential. But it was just like to showcase that we are not pushing only for global warming potential, but also for the other impact categories. But yeah, yep, if you want to add some stuff.
Yeah, no, thank you. That's a really good setup. And of course, the metrics that you're specifically interested in, they depend on the object of your study. And also what you're able to show depends a bit on data availability. In our case, for instance, we have a lot of data on the upstream inventory of chip manufacturing, which is where the majority of impact related to climate change, ADP, and water use is located. If you look at some of the other environmental impacts, such as ecotoxicity and ocean acidification, those impacts mainly come from flows downstream of the fab, such as the waste. They really contribute, in our view, a lot to those impact categories, and this waste is much less well characterized. We have been undertaking a lot of effort over the last few months to characterize those waste streams better, and we will soon be updating our models to actually capture those wastes, hopefully increasingly accurately, and with that also support the EECONE use cases with all 16 impact categories used by the European Union in the EF 3.1 framework. That maybe also touches a bit on the other part of the question related to interoperability of different tools. It is then, of course, important that you are able to agree if you are using one tool, for instance, at chip level and one tool at system level, that you communicate in a language that is common. So either you exchange the inventory of your study scope directly, or you use the same LCIA method, for instance, the European Union's EF 3.1 framework, but you can, of course, also agree on another standard like recipe or Tracy. Hope that somewhat covers the points, but happy to follow up.
I think thanks, Joe. I think that was clear, and thanks, Leo. We have another question from Francois. Actually, we're talking about the results we obtained. Do you plan to validate or certified by a third party the LCA tools, the results from the LCA tools? I think that's a question for everyone here. I don't know who wants to start.
So maybe related to the eco-reliability mini tool, today it's focusing more on an approach that the tool itself. It's more a proof of concept, and that's why we have these examples where you can find what you can do with the tool. For now, it's not focusing on having a tool with an interface and everything done by EZM, but more introducing new concepts and new approach that would be used in a tool later on in that case.
And if I can complete from 3DS side, the LCA results we got from the different use cases, we already validated them with by working with ForMod many times. Olivier, don't hesitate to complete, but we work with Edmund Whitemore, who is a professional LCA expert, and we cross-validated the result with him each time.
And we did a recent study with the CSEM as well. On some of electron production process that we have validated with the expert. But I have a question actually for the person who asked the question, because it said, I mean, the question was about the tools. So hearing Leo questions, I was wondering if we are talking about how the tools themselves are validated, because I said that I was focusing more on the results. So is this the questions regarding how do we validate? Because some of the tools are developed within the ECONE project, or are we considering the LCA result? Which part is the question for? Are we talking about the tools or the results from the tools?
I mean, that in itself is a good question. You can, of course, review the methodology and the data, and then, of course, the results that you get are a combination of methodology and data. For instance, our tool, the methodology itself is reviewed by Fraunhofer through an audit process, which may be an overkill for some, but for us, it's something that the industry organizations that we work with very much appreciate, and Fraunhofer is able to assess the validity of the methodology. The data itself, you can review with end users who have certain expectations and expertise, as already mentioned by Lena and Leo. And that kind of also touches a bit on what I think, in my view, is the best way of validating beyond things like audit is benchmarking. So do the results that your model predicts actually stack up to evidence that you have from your end user or from external parties outside?
Actually, the assessment we did with the CSEM, we used two different methodologies, and they are aligned with the industrial benchmarks. So that's where we have validated the results. So yeah, we were using the same method. I have a question in the chat actually for Andrea. Is the platform open to consult? And the remark would be very interested in the LCA study of the PCBs.
Well, this is basically a question that should be probably more directed to the consortium itself. Well, the platform currently is basically a combination of existing tools from partners. So even we ourselves during our workshop, we have been using rather more presentations of the concept. So we didn't show exactly the tools in itself. So I think that if you're interested in the tools, we can connect directly to the partner who is in charge of deploying the tool in the platform. I think this is probably doable, but that's then a decision of the partner how to manage with that.
I confirm, Andrea, it's doable because the partner who are in charge of the platform are Chiara and myself. So yeah, you can contact us through Andrea. Perfect. And we'll be happy to share some of the, when possible, share some of the platform element and results and so on.
And in the chat, we have the answer to your question, Olivier, for both the certification for the LCA result and the tool itself.
I think we answer quite exhaustively on the result part. I mean, the tool is also the methodology, and as you mentioned, Chiara, the metrics, and I mean, the tool itself. And I think Job also gave some answers because comparing the results and is the tool working appropriately with the industrial benchmark. And I think one way to validate the tools, as Lena presented, is having end users actually using the tool in terms of usability, and I think that's a way to I think validate the ergonomy, the usability of the tool. As Chiara mentioned, you can have a perfect metric, perfect methodology, but if the tool is not usable at the very end, you won't be able to take any decisions regarding creating more sustainable products. But we are also considering some. We have tools with different maturity that have evolved within the project duration. So we assess regularly the advance and the maturity, and we have regular reports so that we see how the tools integrate and evolve along the project life cycle. I think we have a question in the chat. You want to take the question, Chiara, or?
It is for the contact email to ask whether the partners can share some data. I can share my email address in the chat.
Yeah, we'll do the same.
Do you want all the email addresses in the chat, or are you then providing the other ones in case of questions?
I think that we can provide the emails, the email of Olivier and myself, and then we can transfer the question to the presenter. I don't see other questions in the chat. I think that we can end the webinar.
It's time, yeah. Right, Chiara. You want to conclude, maybe, Moritz?
Yeah, thank you very much for dialing in. Thank you very much for the very nice presentation. Also the question and answer. I think that always helps to understand the topic much better. So thank you. I think we will hear from each other again because we will have some more to share in the future. So thank you very much for dialing in, and I hope you have a nice weekend.
Thanks.
Thank you very much.
Thank you, everyone. Have a nice weekend.
Thanks, everyone. Have a lovely weekend.
Bye.